Welcome back. We began by talking about Python syntax and an introduction to Jupyter Notebooks. Now we'll take the things that we learned in those first two sections and start to apply them to actually do some data analysis. To do that, we'll also need an additional module or library called Pandas. Pandas is short for panel data and is a data format that's used for longitudinal studies or studies that happen over many years or time periods. What Pandas will allow us to do is to take data that exists from like an Excel spreadsheet and bring it into Python and manipulate it. And it does that by taking the spreadsheet and turning it into a data frame. Data frame is a common structure that's used in Python. It's also a structure that's used in Spark, in Julia, and R. And you can think of it like a table that you would see in Excel or a table you would see in SQL. It gives us the ability to have all of these things together so that we can start manipulating it. Since Python can do any kind of work, you can use it to make websites or games or do data analysis, we need to begin by telling Python what we want to do. And so this first line here is declaring or telling Python that we're going to be doing some data analysis. It's very common, you'll see it every time you do something with an analytics notebook or data science notebook, that will begin by importing pandas as PD and importing matplotlib.pyplot as PLT. These are just conventions. So we will bring in pandas as PD, means we'll use an alias. So instead of having to write pandas every time, we can just write PD. Instead of having to write matplotlib.pyplot every time, we can just do PLT. Every time you look at like one of the notebooks from SageMaker that's going to be using analysis, you'll see an import statement that brings in these kinds of things. This line here is only needed because we're using a Jupyter notebook, and it tells the Jupyter notebook that we want to see the plot result in this notebook and not somewhere else. Right? So that's not needed if you use a different kind of IDE like Cloud9 or Spider or some of the others. Okay, so we'll start by bringing that in. And now we're going to use the pandas library to do this method of bringing in data. You can see it works just like a function. It's got these parentheses, and inside there's a parameter. That parameter is the location of the data. So we go back here. This is all of the notebooks we have. We have a folder called data, within which there are multiple different files. This is the decline curve analysis we did before. And we will be bringing in the one called sales_fake, so fake sales data. Great, so we've done that. I did shift enter, you can see it changed to 9. I now have this object called sales. That object is a data frame, and it contains within it all of this information. So if I use the method head, I can see that I have the top 7. We can do the top 10. These are the first 10 records. If we bring in something here with read_CSV, it's going to automatically give us an index unless we tell it not to. And then we also, for this data, we've got an ID, order day, order week, the GL, product family, units, and ops. Right, so we can change this 10 to be 17, and it will give us the first 17 items. Remember, we index at 0, so the 17th item is actually number 16 here. That's if we want to see the top 10 by order, right? Not by value, but the top things that were in that list. We can also see tail if we want to see the bottom items. So these are the last items that were part of that data frame. There are a lot of other methods that we can use. So we can look at counts and describes and means. Let's do describe here. Describe is going to give us information about the 3 numeric columns that we have, the marketplace ID, units, and ops. So marketplace ID is the value of 1 for all of the observations. So this is not very useful information here. But for units and ops, it is useful. We can see the total count. There are 20,605 of them. the mean, standard deviation, we see a min, max, we get a sense of distribution of that. We can also change this to info and get information about the data type, so of what this is. And this is an integer, 64. We have objects. That's why they didn't show up when we did the describe. It can't tell us the mean of an object or a string. And then our units and ops are floats instead of integers. Those are floating point numbers. Also, it's taking up 1.1 megabytes of space. All right. So this is telling us information about the overall data frame of sales. But if we only care about one column, then we can look just at that by using the square brackets. And so here I've got sales, and then within square brackets I can put the name of the column I'm interested in. So I'm looking at units, and then a method name, so mean. So we can get, that's the mean for units. I could change this as well to standard, that's a standard deviation, or I could do count and just get how many objects are there. So I can do that because I've put them in square brackets. This syntax of the overall data frame segmented by the brackets is a really key part of working with pandas. So we notice that there's some things here that we can't use, right? So let's look at this. We've got the order day, the GL, the ops. So we've just kind of reordered these things, and we look at the top ones. If we wanted to see what are the different products we have in our product family, we can use the unique method. So there are 4 of them. They're all objects, so consumables, soft lines, hard lines, and media. And if we use value count, it will actually tell us how many, kind of the breakdown of these. So there's 10,608 hard lines. Just a way to see how the data is broken out. Before we had used sum and then parentheses and put like a list. Now, because we're using a data frame, we can apply this method to that column of data, and it will tell us the sum really easily. Right, so we'd use mean, standard deviation, sum. Those are all different methods that we can apply to that column. All right. We can also create new columns by saying that we have a new column. So we're going to take the data frame, we're going to use the square brackets, we'll put the name of the column that we want, and then we'll tell it a value. And so if we say this, the country is US, it's going to apply that value for everything. So everyone here will have the value of US because we didn't tell it anything else. So every observation is in the US. So that is a way to add columns. We can also manipulate columns. We can do things. So we can take our ops and we can divide it by units. And so we get a value for each observation. So if we, it's not very useful in this format. We can assign it to something though, so that will be more useful. If we do sales and we'll call it ASP, and this will equal sales of ops divided by sales of units. So now we have a new column of data called sales ASP, and we can look at this. We can see the mean is 56.9, standard deviation, the min, and the max. Right, so that's the spread here of our ASP. Often with analytics, we want to look at subsets of the data or slice it in different ways to find something of interest. And so we can use that by using this LOC method. So we're going to do sales LOC, so the location where, it's like a condition, the sales GL is equal, so is the same as the pantry. So we're going to do that, and we're going to save it as a new object called pantry. It's going to create a new data frame for us, where everything here is just in the pantry. Okay, that's a way to subset our data, and if we look at this, I'm going to add another one here. We can see that there's 365 of these instead of the full data set, which is 20,000. That's for one condition. Sometimes we want to add additional conditions, and we can do that here by just using the ampersand. So we've got condition 1, so you've got location in brackets, and then within it we have two conditions held by parentheses, where the order day is equal to this date, and where the GL is apparel. So we can execute this, and there's only one that comes back. There's only one softline apparel that was sold on that day. We can see the other columns we added for country is US, and the ASP for this one is 19.7. This notebook has spaces for you to come in and work through some exercises, so I will leave those so you can have a chance to try them on your own. So now we've gone through and we've kind of manipulated some data, we've created some new columns and done some basic math. Let's do a visualization. We'll start off by creating a new data frame called toys. And we're going to take toys is the data frame, we start with the original data frame, but just where the GL is equal to toys. We'll do .copy so that it actually creates a whole new set of data rather than just referencing back to the original data frame. This means if we manipulate anything in the second data frame of toys, it won't affect the primary data frame of sales. Then we're going to create a new index. The index will by default be whatever number it was from the original data frame, but we're going to change it to be the order day, and then we'll plot it. So this is a time series plot where you can see the toys by day. Not terribly beautiful, but a good way to get a sense of the data. Matplotlib is really great at doing these basic plots. If you wanted something that you were going to show a customer, there's a lot of other options that would make much better looking plots. If we decided instead that looking at ops that we wanted to look at units, we can just take the same here and I'll change ops to units, and it looks like it follows the exact same pattern. Okay. Okay. We can do multiple plots. These are our kind of subplots. So you can see units and ops. We just created those two plots above, and the ASP, all created together. These have different indices, so it's good that they're separated out and not all on a single chart. It's an easy way to do it, and we did that by doing subplots is true and providing 3 columns of things that we wanted to have returned to us. Pandas automatically can do these time series plots with this method plot if the index is a date. So that's important that we change the index from being a numeric value to being the date, so that it can put things in order. You can also do things like make histograms very easily by just using hist, right? That's a method hist, and we can tell it how many bins we want. 20 if we did 100, you get a little bit more variance. You can see that it's not normally distributed at all. It's skewed positively a lot because there's a couple values that are extreme out here. Easy way to get a sense of the distribution of the data. You can also do a box plot do box plot. Okay. So we have now done some manipulation of the data, and we can save it back to the folder we looked at before that had the data. We'll do that first. We're going to make an object that is the name of where we want this data to go. And then we will use this method toCSV, so that we're telling Pandas, take the data, save it as a CSV to this path, and in this case, don't save the index. The index would be, again, those numbers, the 1 through 20,000 that were applied automatically. Right? If we were not using SageMaker, if you were doing this on your local machine using something like PyCharm or Anaconda, you can get another feature within Pandas to clipboard, to copy to clipboard. This will take the entire data, but copy it into a clipboard, basically like a big Command C. You can open up Excel and paste it. It won't work here because it requires a module that we don't have because we're working in SageMaker. There is an alternative syntax here of doing dot instead of the brackets. So sales.gl unique is actually the same as sales bracket gl dot unique. These are the same. This format comes from more of a traditional web developer type approach, but this format is preferred in the data science world because it's much more explicit as to what you're doing. So we kind of save the dots for methods, and we do, if we want a series or then we'll use the brackets there. There are lots of things here. You can go through and work through those. And that is our basic introduction to doing data analysis with Pandas. In the next lesson, we will do some more advanced concepts, and we're working up to being able to actually apply these to a real data set and find some interesting patterns in the data.